what we're looking at today is factorising monic quadratic trinomials. So those are some really big words that we're using at the moment. So just to break down this word, the first thing that we're going to look at is this idea of a quadratic. So a quadratic is an algebraic expression where the highest power of a pronumeral is 2. So normally when you're looking at the pronumerals, you've got the same letters that you're using, but then you may have a square in one of them. So an example would be something like x squared plus 4x minus 2. Okay, now when we're looking at a quadratic, we're looking at a square term, an x term, and then possibly a constant term as well. Something like 1 minus x squared, you could also consider to be a quadratic. You could have 5x squared minus 2x. That would also be a quadratic, because when you look at your x, the highest power for each of them is 2. The other word that we look at is this idea of a monic. When we're talking about a monic, it means that the coefficient of the highest power is equal to 1. So remember, the word coefficient means that you're looking at the number in front of the pronumeral, okay, so the number in front of x, or if we're looking at the highest power for each of our quadratics should be a square. So we're looking at the number in front of the x squared. If the number in front of the x squared is 1, then we can say that it is monic. So if we look at these three examples that we've got here, the first one, the x squared here, does have an imaginary 1 there, so that's going to be monic. If I look at the second one, then the x squared, well, that's actually a negative 1, so that's non-monic. Okay, so we just say it's not monic. And if we look at the last one, you can see obviously we've got a 5 as our coefficient of x squared, so that's also going to be non-monic. So we've broken down the word. We know what a monic now means. We know what a quadratic is, and the word trinomial. Now I did sort of mention it earlier in one of our previous videos. Trinomial, so we talked about binomial. Binomial meant there were 2 terms. Trinomial means that there are 3 terms in the expression. So when we look at these 3 that we've just written out, that first one is a trinomial. So the second one, that's only got 2 terms, so we could call it a binomial, same as that one as well. So the bottom 2 are binomials, this one's a trinomial. And what we're aiming to do today is we want to factorize these sorts of things. So this expression right here is a monic quadratic trinomial. And what we want to do is factorize it, which means we want to create double brackets back out of it. If we talk about just a basic trinomial, a quadratic trinomial is an expression where we write it as ax squared plus bx plus c, where a, b, and c are numbers. So you can see it's got a similar form to what I've written out here, only we haven't specified exactly what those numbers are. If I'm looking for a monic quadratic, then what I'm doing is I want the a value to be equal to 1, so I'm only going to have numbers for b and c. Okay, so that would be the format of a monic quadratic trinomial. Now we're just going to go back a couple of steps. Remember when we were looking at expanding brackets, expanding binomial expressions, what we did was if I had a pair of double brackets, I was going to use FOIL, okay, in order to work out the expansion. So FOIL, F for first, multiply those together, and there's your x squared. Then your outside, so x times b, I've written as bx. Inside, a times x is ax. And then the last terms is a times b. Now we've got our x squared, we've got 2 terms of x, and then we've got some sort of number there. So what I've just done here is I factorized out x, okay, and then I've got an a plus b inside of a bracket. So if I gave you something like x squared minus 4x plus 8, and I said I want you to factorize it, then what we want to do is we want to compare this to this expression here, because that's going to help us to work out the two numbers in the double brackets. So what we know is, we know that the coefficient of x is the sum of the two numbers that we had there. Okay, so that's your coefficient. And then the last number is the two values multiplied. So that's going to be a product. So what we're going to do is we need to first find a pair of numbers that add to give the coefficient of x. Okay, so two numbers that add to that, and multiply to give the constant, to give that one. What we then do is we split our trinomial into 4 terms, okay, by splitting the x term, and then we're going to do a grouping in pairs. Okay, so that's the process that we're going to go through. So the way that I usually set these out is I use SPF. So I draw a little table over here, and I'm going to put SPF. So S for sum, P for product, and then F for factors. So the sum is going to be the coefficient of x, which is that number there. So we're going to have positive 4. The product is the constant, okay, which is the number that's by itself. So we've got positive 3. So what we need to do is think, what are two numbers that add to give 4 and multiply to give 3? Okay, so hopefully it wouldn't be too hard for you to work out that if I have 1 and 3, that will satisfy that condition. So if I have 1 plus 3, that's going to equal to 4. If I do 1 times 3, that's going to equal to 3. So those are the two values that we want. What we're then going to do is we're going to take this expression, and with that 4x, we're going to split it into a 1 and a 3. So we're going to have x squared plus 1 lot of x, or just x, plus 3x, then we'll put the plus 3 on the end. So we leave the x squared there, we leave the 3 there. The only thing that we're changing is we're splitting the 4x into 2 parts. What we can then do is we've got 2 pairs of terms that we can group in pairs. So x is common in the first bracket, first 2 terms. So we've got x plus 1 left. And then in the second 2 terms, plus 3x plus 1. And so you can see now we've got our 2 common brackets. So that's x plus 1 and x plus 3. And that's your factorization. If we come to the next one, again, draw up a box SPF. We want 2 numbers that add to give -7, and they multiply to give 12. So 2 numbers that add to give -7 and multiply to give 12. Now, because the product is positive, what we know is that we want either 2 positive numbers times together or 2 negative numbers times together. Now, if you notice, this sum is actually a negative value. So if I add 2 positive numbers, I'm not going to get there. So I actually need 2 negative numbers. Now, if you can't work out what the numbers that times to give 7 are, what you might want to do is write out your factors in pairs. So 12 has the factors of 1 and 12, 2 and 6, 3 and 4, and that's it. So what we want to do is look at each of those pairs, which of those pairs are going to give us -7, and it's going to be 3 and 4, except we need the negative versions of each of those. So -3 and -4. So when we go to work out our factors, what we need to do is we need to look at both the sum and the product together in order to work out what numbers will work. So because our product is positive, either both the numbers are positive or both the numbers are negative. Because we know the sum is negative, then we must have 2 negative numbers. So what we're going to do now is we're going to write out our terms, plus 12, and we're going to split that -7m into -3m minus 4m. Then we're going to factorize by grouping in pairs. So the first two terms, m is common, so we've got m minus 3 left. When you look at the second pair, can you see, because we're aiming to have m as positive, but right now it's negative, we're actually going to take out minus 4 as a common factor. So when we take out the negative 4, both of the signs are going to change over, so then we'll get m minus 3. If we didn't take out the negative and we just put a plus in front of it, then we'll end up with negative m plus 3, which is not the same as this. So the brackets need to be identical in order to be able to factorize them. So they are now. M minus 3 is the common factor, and then what we have left is m minus 4. Now, some of you may have already noticed, or some of you may not have, and that's okay. If you look at these factors here, so let's come back to A, this one and a 3, have a look at what we've ended up with in our final line. Can you see that? It's actually exactly the same, and that's actually a shortcut that you can use. So when we do our grouping in pairs, what we end up with is whatever the factors were, they're actually exactly the same as the values that we'll put into the double brackets. If you look at the second example we did, we had the minus 3 and the minus 4, and you can see in your brackets, again, you've got the minus 3 and the minus 4. So what I would suggest is do the grouping in pairs a couple of times, and once you're confident with it and you're comfortable with it, you can use the shortcut. You don't have to do it the long way every single time when we're looking at monic trinomials. All right, let's have a look at question C. So again, SPF. I know some other teachers use PSF. I like SPF because you can remember it like sunscreen. So sum product factors. The sum in this case is -1. The product is -6, and we want to find our two factors. Now, if the product is -6, that's a negative number. It means that one of the numbers has to be positive and the other one has to be negative in order for this to work. So again, when we're looking at 6, we can write out some factors, 1 and 6, 2 and 3. And so you can see 2 and 3 is probably going to be the one that will help us to end up at the value of 1. Well, -1. So if I've got 2 and 3, then in order to get -1, one of them has to be negative. We're going to have +2 and -3. So if I have 2 times -3, it is -6. 2 minus 3 is -1. So we know those are the values that will work. Now I'm going to do it the long way. Actually, I'll write out what our final answer should look like. So if you use the shortcut, we've got a plus 2 and a minus 3. Okay, so remembering that we're looking at, go pink, these numbers here, those numbers go into your two brackets there. Okay, so if I do it the long way, if I solve this the long way, then a squared plus 2a minus 3a minus 6. So what I've done is I've split that minus a into those two terms, and then I'm going to group in pairs. So with the first two terms, we've got a as a common factor. A plus 2 is what's left over. When we look at the second pair of terms, you can see that you've got two negatives, so we'll take out -3 as a common factor, and then it's a plus 2. And then so you can see that a plus 2 is common, that's our bracket, our first bracket, and then everything that's left over goes into that second bracket. Alright, one more example. So q squared plus 5q minus 6. So again, SPF. We want two numbers that add to give 5 and multiply to give -6. Let me just move those questions down a bit. So if we need two numbers that add to give 5 and times to give -6, we can see our product is negative, so we're going to need a positive and a negative number again. So if I'm looking at 1 and 6, 2 and 3, well, if you look at these combinations, 2 and 3 can give us a 5. 1 and 6 can also give us a 5. But what we need to do is we need to work out what combination will produce the positive and the negative values that we have here. So because we need one number to be positive and one number to be negative, we actually need to use 1 and 6. So if I need the sum to be positive 5, I'm going to have a negative 1 and a positive 6. So this is one combination that does get a little bit tricky because there's two different ways. So you can use 1, 6 and 2, 3 to get a 5, but you need to pick the correct version in order to have the signs the right way around, like positives and negatives. So we're using negative 1 and positive 6. So q squared minus 1 lot of q plus 6q minus 6. So q is common in there, and what we have left is q minus 1. When we look at the second pair of terms, then 6 is common, q minus 1. Again, there's your common bracket, q minus 1, q plus 6. And that's how we factorize trinomials. So again, you can use your shortcut. So if we look at the factors here, those two numbers can actually go directly into the brackets. But it's important that you do pick the right numbers and the right combination that's going to produce the correct result.